In section 4.3, we're going to be talking about applying algebra, which means word problems. So we're going to practice some techniques for solving word problems. This seems to be an area where people really struggle, so try to pay close attention to this, replay the video if you need to, and then when we're working together in class, ask lots of questions and be patient with yourself as you learn this. So we're going to use the steps for solving word problems that we have been using all through the class from Module 1. Start by defining the variable, write an equation, solve the equation, check the answer twice, and answer in a sentence. So we'll always use that same process, but of course the hard part is not the steps, it's the interpreting the word problem and making the steps happen with a particular word problem. So remember, as we talk about these, that these aren't rules to be followed, and they're not. They are a step-by-step procedure, but you can't just follow the steps and have the word problem automatically get solved. When we teach you to solve, say, two-step equations, we can do that. We can show you what the steps are. We can have you practice it, and every time you can solve a two-step equation if you follow our steps. But word problems aren't like that. They're more complex. So the things we're going to talk about are not rules, they're good techniques for solving word problems. So I like to make the analogy that when I learned to change the tire on my motorcycle, I asked expert friends for their techniques and tips, and I watched lots of YouTube videos looking for little tips that would help. And so think of the tips that we give you in this section as the tips and techniques from experts, people who are really good at this. So the tips we're going to work on don't make the word problems easy, they make them easier. Changing my motorcycle tire by hand was still a royal pain. Even after I watched all those videos, asked for all that advice, it's just not easy changing a motorcycle tire by hand with hand tools. So there's still cursing involved, skin knuckles, but I did get the tire changed, and I didn't pinch any tubes, I didn't get any flat tires, so it worked out. It wasn't easy, but without the tips I got, I would not have been able to do it. So all those tips that I got from all the people that had done it before me helped me out, didn't make it easy, and I still had to practice at it to get better at it. So these are the tips that we're going to talk about. Use words, make a guess, visualize the problem, and reduce the clutter. So we'll work some examples, one example of each of those so you can see what we mean by that. So the things that we ask you to keep in mind when you're doing this is read, read, read. That means every time you hit a word problem, and even those of us who have done a lot of these and are really good at it, we have to do this. I certainly have to read long word problems more than once. I don't read through it quickly and then the answer appears in my head. So I have to read it several times. I have to persist. I have to just stick with it. Sometimes I get started in the wrong way and I realize that's not going to work, and I back up and redo it. And be resourceful. I guess that's a little hard to define what we mean by that, but we're just saying keep at it, look at it at different angles, get some help, that sort of thing. And then give it a rest just means if you're banging your head against the table on one problem over and over and over, sometimes it helps to take a break from that problem and come back to it later, and you'll see an answer better later on. So the first tip we're going to try is use words. And so what we mean by that is that sometimes it helps to take a complicated word problem and sort of boil it down into expressing the mathematical relationship in words. So obviously the word problem has a lot of words in it. But we're talking about simplifying the situation down to as few words as possible. And sometimes when you do that, it really helps you find the equation that you need for your problem. So for some students, when we use variables, it's confusing. Just something about using an X to stand in for something is confusing. So if that's true for you, this might be a particularly useful tip for you, because what this does is starts out talking about the mathematical relationship that shows up in a word problem, but does it at first without variables, uses phrases and sentences instead. And so sometimes that helps you think through the problem, and then you can put the variables in later. So here's our example problem for this one. It says, do not solve the following problem. Use the information in the problem to apply the problem-solving tip of use words. The ski club organizes weekend trips to a particular ski area and regularly charges $325 per person for transportation, lift passes, lodging, and meals. However, if a lot of people register for a trip, the cost is reduced by $2.25 per person. How many skiers must participate in order for the person-to-person cost to be $235? So if you're like me, when you read a problem like that, it's a little confusing at first. Lots of numbers. They're talking about different things that are going on. And so I want to go back to that first thing about read, and persist. If you read all the way through it and you're not there yet, that's the way I am with a problem like this. I don't immediately see the answer when I read it, so I go back and read it. Now, I'm not going to bore you by rereading it right now, but if you want to reread it, pause the video, read it again. So what we're trying here is this process of using words, and so I'll show you what we mean by that. So we're going to start out by summarizing what the problem is in as few words as possible. So there's lots of stuff going on in there. We're just trying to boil it down, and remember, we're looking for the mathematical relationship because our question is how many skiers must participate in order for the person-to-person cost to be $235. So we know we're looking for a number. So when we say summarizing what the problem is about, we mean summarize what the mathematical relationship is. So here's the mathematical relationship. The regular price minus the reduction equals the cheaper price. So let's go back and see where we got that. Go back to the problem. It says a ski club organizes weekend trips and regularly charges $325 per person for transportation, etc. So the regular charge is $325. However, if a lot of people register for the trip, cost is reduced by $2.25 per person. How many skiers must participate for the per person cost to be $235? So that's where we got this sentence. We go back, reread the problem, and realize, well, there's a regular price for these weekend trips, but then if they get enough people, they reduce the cost. But and so we're not, at this stage, we're not worrying about what the exact reduction is. We're just saying, well, there is a regular price and there is a reduction, and if we subtract them, then we'll get the cheaper price. So we're not at this moment putting any numbers in, worrying about exactly what it is. So then, if we can get it down to that sentence like that, that sentence describes the mathematical relationship between the regular price, the reduction, and the cheaper price. And we're going to be able to really quickly get ourselves to an equation from there. So our equation is, we're just working right off of this sentence that we made. So regular price is $325 minus the reduction. It said the reduction was 225 for each skier. And again, right at this stage, we're not trying to figure out how to express that 225 for each skier mathematically. We're just putting in the phrase because we're trying to keep you away from having to worry too much about variables at this stage. And then the problem said that what we want is for the cheaper price to be 235. So for the cheaper price, we put in 235. So now we're going to go slightly further, and then we're going to say, so 325 minus 225 times the total number of skiers. So we just advanced a little bit by saying, well, how would we figure out 225 for each skier? We would do 225 times the number of skiers, but you notice everything else about that equation is still the same. So we've written out our relationship in words, and now we're ready to keep working on the problem solving techniques. So I just want to remind you that this is our process. So the first thing we're going to do is define the variable, and then we're going to write an equation. Now, because we're working on problem solving techniques, we're not going to do the last three right now. You all do that when you work on your homework problems. But we're going to define the variable and write an equation. Okay, and the way we've done this, it's going to be really easy because we've got it worked out here. So if you look at the original problem, it said up here how many skiers must participate in order for the per person cost to be 225 or 235. Remember, we've typically said that you can look at the question that you're trying to answer, and that will frequently tell you what the variable should be. Plus, we can look at our equation, our verbal equation that we wrote right here, and we can see what that might be. So we're going to use T equals the total number of skiers. And then the next thing in our problem-solving technique is write an equation, and that's what we've been shooting for all along. So we take our verbal equation, and we're just going to make it into an equation. So 325 minus 225 times T, which is our total number of skiers, and that's going to be equal to 235. So I'm just taking this and translating it into equation form. And then because we know how to write equations in algebra, we know we don't need the parentheses in this case. We can do like that. Now what I notice when people work these word problems is this is the hard part for them. A lot of you actually do fine with figuring out the mathematical relationship. What you have trouble with is putting it in equation form. And we've talked about this in class, and people say, well, if I can see the mathematical relationship, why do I need to put it in equation form? And the answer to that is, as the problems that you run into get more and more complex, they're going to get harder and harder for you to just intuitively see all the mathematical relationships and sort of solve it in your head. And so you want to get good at this process of building an equation out of a word problem. So that's our first tip, and we'll go on to the next tip in the next video.